Today I want to give you an introduction into the SGE Calc Channel Guide, a tool to create calculations, for example to create calculated channels in the data artist. But let's start from the beginning. We are in the data artist and have already some data loaded from an emission test in this case, and in the lower area here we have a throttle position. This is a measured value, a relative value between 0 and 100%. And now we want to add an additional calculated channel that contains the physical throttle position, knowing that the range of 100% is in physical units 85 degrees. So we add a channel and now we choose a calculated one. And then we get this little window where we can start the Calc Channel Guide by pressing the button for the calculation. Then we get first an empty window. This is the Calc Channel Guide main view. And now we will start to add some objects to perform the calculation. We have two possibilities to add objects. First, we can use a graphical way. Then this channel object inventory is shown where we can choose from a list of all available objects just by double clicking. So for example, we just double click the result object and then we are asked how the calculated channel should be named and which unit it should have. We confirm this. I already entered it. And then we have our first object here. Afterwards we need some more objects. For example, if we want to calculate this throttle angle, we have to access the measured relative throttle angle. We do this using a channel object. We will need some multiplications and we will need a constant. After adding our blocks, we can close the inventory. The second way to add elements is to add the my name. This is a quick way using a drop-down dialog. If we know the name, we can just type it in, press enter, and we get the block added. So now we have to edit some blocks. We just do this by double-clicking them, and then we get an options dialog starting with an introduction. And in this case, for the channel object, we can now, for example here, say that we want to read the throttle position from the file. Specifying the calculation is done by connecting the objects with lines. We do this with the mouse when the shift button is pressed, and we drag a line from the source to the target object. Like this. Now let's edit this multiplication because we need first a division and then a multiplication. What we want to do is to divide the throttle position by 100% and then to multiply it with 85 degrees. So we modify our constant here to have a value of 100 and the second one to have a value of 85. We can also mark multiple blocks, connect them at once. And finally connect the multiplication to the throttle angle. Now the calculation is finished and we could just confirm and exit the Calc Channel Guide to start the calculation in the data artist. Let me show you some more options that we can perform here. We have undo redo history to undo and redo actions that we did this session. So also using keyboard shortcuts we can undo and redo things. And we have also the possibility to use a history. The history stores complete sessions, calculations from further sessions. So if we jump to the next history entry here, we can jump to calculations that were done before. And we can of course go back to our calculation that we created. This history entries and the calculations can be saved to a file and loaded from a file. This way it's possible to store calculations for later reuse. To tidy the calculation a little bit, we can use line branches. These are created by double-clicking a line, and then we can avoid, for example, line crossings by creating these line branches. Some color indicators help us to detect errors in the calculation. So for example, if I delete this line, we will see that the two unconnected blocks are marked with a red border. In order to test the calculation, we have the possibility to perform a test calculation. This test calculation is done using some random input data, and all objects evaluated correctly during the test calculation are shortly shown with a green border color. If an error occurs during the calculation, the corresponding block is shown with a red border color. To show it here, we modify this constant to be a vector. And if we now perform the test calculation, we will see that we get an error message saying that the multiplication cannot be executed because the matrix dimensions does not agree. Additionally, we have the possibility to check our calculation using so-called visualization objects. We do this by adding them to a line. This means that when the calculation is evaluated, the data at this point of the calculation will be shown in an additional window. Okay, now let's perform the calculation, creating the calculated channel in the data artist. We confirm and exit. This way we return to this window here, where we started the editing of the calculation. We also confirm here, then the calculation is done, and the channel is added to the data artist. Now we have our throttle position in a physical angular dimension. As we have seen, the visualization window was opened, and if we expect some problems with the calculation, we can use a visualization like this to analyze it afterwards. We can zoom here, we can inspect data points to understand what's happening during the calculation.